Geometry, determining a sequence of rigid motions. So far in this unit, we've discussed three types of rigid motions. We've discussed rotations, we use a capital R, reflections, which we use a lowercase r, and translations, we use a capital T. These are the three rigid motions. And this is how we can move triangles and figures around, and they are called rigid motions because they preserve distance. They produce a congruent image of itself. The side lengths of what they were are still what they are, and the angle measures and so on are preserved. So what we're attempting to do here, this is not constructions. We did constructions for all three of these. But now we want to kind of just describe how would I go from one figure to the other? How would I map something on top of something else using these motions? And you have to be pretty precise on how you explain that. This first question is just saying that this triangle ABC is congruent to this triangle A prime, B prime, C prime. What rigid motion or motions map this onto this? You know, how could I take this triangle over here on the left and get it to fall on top of this triangle using these three tools here? And this would simply be a single rotation. A single rotation can do that. Now, when they say describe, we can't just say rotate. You have to be very precise. When you are referring a rotation, you have to say what point you're rotating about, because you know this triangle here, if I were just to highlight this for a second, you don't need to draw this yourself. Let me highlight triangle ABC. And pretty sloppy, but it'll do the point. If I rotate it around point B, it would look something like this. Is that where I want it to fall? No, if I rotate it around point A, it'll look over here. If I rotate it around point C, that's what we're looking for. So you have to make sure that when you say you're doing a rotation, you have to say what point are you rotating about. At least that's what we're going to start with. So we'll say a rotation, fix that T, about point C. A rotation about point C. You could say around point C if you don't like about. A rotation about point C. Now, not only do you need to say what point you're rotating about, you also have to say by how much. Now, this is a 180-degree rotation, but they're not always going to be perfect 180 degrees. And we're not going to always know exactly what the angle of rotation it is. So what we could say is a rotation about point C so that side AB maps to A prime, B prime. And basically what that's just saying is rotate this triangle until, whatever degrees it takes, but until this side falls on this side. And when that happens, I know the triangles will be on top of each other perfectly. So did it have to be AB onto A prime, B prime? Could it have been AC onto A prime, C prime? Yes. Could I have just said until angle A maps to angle A prime? Yes. But it's a little bit better to say sides because there are ways for things to map to angles, but then the sides don't line up perfectly. But we'll get into that a little bit. But right now, I just really want you to take away that when you're using a rotation, you have to say what point you're rotating about and until this maps to that. You know, specifically how much are we rotating. When you use a reflection, you have to say what line you're reflecting across. You don't have to say by how much because reflection, there's only one way to do that. But you do need to specify what line you're reflecting across. And when you use a translation as your motion, you have to say by what vector. How much am I moving it? And it's just basically from this point to that point. But we'll see that in these next examples. All right, so this figure here is a bunch of isosceles right triangles. I want to describe a sequence of rigid motions. It's called a sequence because it can take more than one in a lot of these cases. That will map triangle ABC, this triangle here, onto CGF. So CGF, this triangle right here. So I can't get from here to here in just one motion. So let me actually, I'm gonna keep a little check here, a little check here, so I remember these triangles. But I'm gonna highlight it again. Again, this is something that you can't really do because you don't have the digital tool that I have. Maybe someday. But let's see. Now, if I want to go to this triangle, can I just translate? Can I just shift it over? It doesn't fit perfectly. Can I just reflect it? Well, if I reflect it, let me clone it, and if I flip it, Like upside down, well, it's going to fall on this triangle, not where I want to go. And if I wanted to reflect it the other way, if I want to flip it this way, it would fall over here if I reflect it over that line. Again, not quite where I want to go. So I can't do this with a single, how about a single rotation? Well, if I rotate about point C, let's see, if I did like a 180 around point C, it would fall like that. Again, not exactly how I want it to be. So that's why it's going to take a sequence. And there's always multiple answers to these. So if you're working with a partner in a group, there's a good chance that you guys will have different answers, but they're both just as valid. So there's definitely more than one way to do this. And sometimes the questions will say, describe 2 different ways to make it happen. So one option is I could turn this triangle, I can move it to this triangle. What would that be? It's a move, right? It's not a reflection, it's not a rotation, it's a translation, it's a shift. And so that's my first step, is I'm going to translate to that triangle to the right of me. So I'm going to say it as a translation by vector, translate by vector. Now, how much did I move? Well, how do I describe the vector? Just pick a couple of points. Pick a point, and where did the point go? Point B started here, and then when I moved the triangle, it landed at point E. So we'll say by vector BE. Remember, vectors have arrows above them. They're not line segments. They're vectors. They're rays. I could have also said AC or CF. You know, that by that length in that direction. So translation by vector BE. And then what? And then how could I fall from this triangle to this triangle? Well, from here, I could then do a reflection across line CF, and that will land on there. So a translation by vector BE, and then a reflection, move down here, a reflection across CF. That's how I would describe it. Now, sometimes we also want to write this with a notation. And the notation for this is whatever triangle you're starting with, triangle ABC, have that in parentheses. And you kind of are going to work your way right to left, which is a little weird here. The last thing I did, so I'm working backwards, the last thing I did was a reflection across CF. I'm sorry, no, that's the last thing I did. The first thing I did was a translation by vector BE. So translate by vector BE, and then we did a reflection across CF. So this is how I would write the notation of, you know, starting here and you work your way in to out. So the first thing we did was a translation, and then we did a reflection. So that's how you would write the notation. So sometimes we want it like in a sentence description. Sometimes we want the notation. Sometimes we want both. Let's look at a few more examples. ADC onto JIH. So let me just get these pictures here. ADC, so ADC, that's this one, onto, and I'm going to move my highlighter there. That's where I'm starting, onto JIH. JIH, so all the way over here. How can I get from here to here? Well, if you want to get really creative, I think we could actually do a single rotation. Centered at F, rotate 180 degrees. I think you're there. Done. But again, there's multiple ways to do this. Could we do a, how about if I want to get to this triangle here and then reflect? Can I get to this triangle here? How could I do that? Well, I could reflect I could reflect across this line, right? FG. Wouldn't this triangle reflected across this line be this triangle? So when you do reflections, it doesn't necessarily have to be a reflection across a triangle side itself. It could be somewhere like in the middle, and then I'll jump all the way to over to here, and then a reflection across that will get there. I could do that. So that was an option. I could do a translation from A all the way to J, and then rotate until, you know, this side maps to this side, like that, like 180 rotation. I could do something like that. I could do a reflection across AC, get here, and then translate it to here and reflect across here and then translate it to here. So there's a lot of different ways to do this. The one I'm going to choose to say is the second one I came up with. I'm going to say I'm going to reflect across FG. This triangle reflected across this line will be this triangle, and then reflect across HJ to land on that triangle. So a reflection across FG, a reflection across, and what was it, FG, and followed by, and a second reflection across, that second line was HJ. And in the notation, that would be, so triangle ADC is what we're starting with, in parentheses. On the left of that is my first reflection of FG. And bad with my G's today. FG. Hard to write a small G with this tablet. And then after that, we did a final reflection of HJ. But as we said, we could have done it with a single rotation. We could have done it with a lot of steps, 1 step, 2 steps, 3 steps, 5 steps. There's a lot of different ways to solve this. I'm going to skip this last one. We'll talk about it in class. We're going to do a lot of things like this in class. We're going to spend a couple days on this probably because this is an important concept. And it's kind of fun because there is a lot of different ways you can do these questions. So we'll talk more about this. See you there.